close your eyes and picture the most remote place on Earth. Not a jungle, not the deep ocean, not outer space, Antarctica. A continent the size of the United States and Mexico combined. And almost nobody lives there. No cities, no roads, no noise. Just white, endless, blinding white. But here's what most people never find out. Beneath that silence, Antarctica is alive. And it is hiding secrets so enormous, so strange, so completely unexpected, that scientists who've spent entire careers studying this place still look at their data and say, wait, that can't be right. We're talking about a hole in the ocean, the size of Switzerland, that no one can fully explain. A mountain range the size of the Alps that no human being has ever seen. A bird that flew next to dinosaurs. And deep-sea creatures thriving in total darkness under half a mile of solid ice. Antarctica isn't the end of the world. It might actually be the beginning of understanding it. In the heart of the Weddell Sea, one of the most isolated stretches of ocean on the planet, something extraordinary keeps appearing. A hole, not a small one, not a crack in the ice. A massive open water gap punched right through the middle of the frozen sea ice, stretching across an area bigger than Switzerland. Scientists call it a polynya, and what makes this one so deeply unsettling is where it is. Not at the edge of the ice sheet, where you might expect some melting, but right in the center, surrounded on all sides by frozen ocean. It's like finding a bonfire burning in the middle of a swimming pool. This hole first showed up on satellite images decades ago. Then it vanished, then it came back. Then it vanished again. For years, researchers couldn't figure out what was opening it, or why it kept returning to the same spot. Here's what we've pieced together. Deep beneath the surface, at a place called Maud Rise, a massive underwater plateau, the ocean layers behave strangely. Cold, fresh water normally sits on top, acting like a lid that keeps the heat trapped below. But a slow, swirling eddy current in this region occasionally disrupts that lid, pulling warm, saltier water up from the depths. When that warmer water rises far enough, it melts the ice from underneath, and the polynya appears. But that's only part of the story. Because the real breakthrough in understanding this phenomenon came not from satellites or submarines, but from seals. Researchers have been fitting Antarctic seals with tiny sensor helmets, little tracking devices that record temperature, salinity, and depth as the animals dive. These seals go places no research vessel can. They swim under the ice, deep into the cold dark, and they beam back data that no instrument we've ever built could collect. And that data confirmed it. The ocean beneath the polynya is doing something genuinely unusual. The circulation patterns there are unlike anywhere nearby. The heat exchange is happening on a scale that models hadn't predicted. The Maud Rise polynya is a window, a temporary, mysterious window, into the deep ocean's hidden plumbing system. And every time it opens, the planet exhales a little differently. The Antarctic ice sheet is the largest single body of ice on Earth. It holds 60% of all the world's fresh water, locked inside glaciers, some of which have been building for millions of years. If it all melted, which it won't, not anytime soon, global sea levels would rise by nearly 60 meters, entire coastlines gone. So understanding how this ice behaves isn't just a scientific curiosity. It's one of the most important questions our civilization has ever asked, and for a long time, we were terrible at answering it. The problem is that ice doesn't move in a straight line. It doesn't follow simple rules. The Antarctic ice sheet is threaded with rivers of fast-flowing ice called ice streams, some moving faster than others, some accelerating, some that switch direction without obvious reason. Predicting how any of it responds to warming temperatures involves thousands of variables interacting in ways that traditional physics-based models simply couldn't capture fast enough to be useful. Enter machine learning. Researchers are now feeding decades of satellite data, radar surveys, GPS measurements, and ice core records into AI systems that can identify patterns in all that complexity, patterns that no human analyst would have the time or processing power to find manually. The results are starting to transform what's possible. These systems can now simulate ice behavior across century-long timescales with far greater accuracy than older models. They can flag specific glaciers that show early signs of instability. They can map the seafloor terrain under the ice because the shape of the bedrock determines which glaciers are most vulnerable to warm ocean water sneaking underneath and weakening the base. We're not just watching the ice anymore. We're finally starting to understand it in real time, at scale, with tools that learn as new data comes in. Antarctica is no longer just a place we observe. It's becoming a place we can actually read. 66 million years ago, an asteroid struck the Yucatan Peninsula and ended the age of the dinosaurs, or almost all of them, because while the massive land-walking giants were wiped from existence, something else made it through. Something smaller, something feathered, something that could fly, the birds. But here's the part of that story that Antarctica is still rewriting. We used to assume that modern birds, the ancestors of every duck, eagle, penguin, and sparrow alive today, evolved after the asteroid. That the extinction event was what created the opening for birds to diversify and spread across the planet. A fossil found on Vega Island, just off the Antarctic Peninsula, says otherwise. Vegavis iaai, a diving waterbird roughly the size of a modern duck, was swimming in Antarctic waters 68 million years ago. Before the asteroid, before the extinction, before the world reset itself. Its bones tell a clear story. This wasn't some primitive, dead-end branch of the bird family tree. This was a true modern bird, already evolved, already specialized, already living its life alongside the last of the dinosaurs. And the fact that it was found in Antarctica says something just as remarkable about the continent itself. 68 million years ago, Antarctica wasn't white. It wasn't frozen. It sat further north on the ancient supercontinent Gondwana, and it was green, covered in forests, rivers, coastlines. A warm, lush world, almost unrecognizable from the place that exists today. Antarctica didn't just survive the history of life on Earth, it was part of it. A full participant, a living, breathing landscape where early birds flew, ancient seas filled with marine life, and the planet was in the middle of an entirely different chapter. That chapter is buried in the ice now, but every fossil that surfaces is another page recovered. In early 2025, an iceberg roughly the size of a small country broke away from the Antarctic coast, designated A84. It had been locked in place for what researchers estimate was at least a century, a frozen lid clamped over a section of seafloor that had been sealed off from the surface world for longer than any living person has been alive. When it drifted away, it exposed something underneath that science had never directly seen before. The seafloor below was not barren. It was not a dead zone. It was not the empty, frozen wasteland that common sense might predict. For a place buried under 150 meters of ice in complete darkness, cut off from sunlight and photosynthesis. The twin engines that drive almost all life on Earth's surface. What researchers found instead was a thriving ancient ecosystem. Creatures built for a world without light, without seasons, without any of the cues that surface life depends on. filter feeders anchored to the rock and drawing nutrients from whatever drifts down through the water column. Slow-moving organisms living on geological timescales, generation after generation, in conditions that would be lethal to almost anything humans recognize as life. This discovery joined a growing body of evidence reshaping what we understand about where life can exist. Deep borehole cameras lowered through the ice sheet have previously found fish, actual swimming fish, in waters beneath hundreds of meters of ice, far from any open ocean. Life keeps showing up in Antarctica's hidden depths, again and again, in places we were certain would be empty. And every time it does, the boundaries of what's possible expand a little further. If life can thrive in total darkness, under crushing ice, in near-freezing water, ice with no sunlight and no photosynthesis, then what does that mean for the ice moons of Jupiter and Saturn, where similar conditions exist across vast subsurface oceans? Antarctica isn't just teaching us about our planet. It's teaching us about where else, out there in the dark, something might be alive. Deep in the center of East Antarctica, roughly 1,200 miles from the nearest coastline, lies one of the strangest geological features on the entire planet. A mountain range, not a small one. We're talking about peaks that rival the Alps in height. Sharp ridges, deep valleys, ancient river channels carved into rock, an entire landscape of dramatic geography that rivals the most striking terrain on Earth's surface. And no human being has ever seen them. The Gamburtsev subglacial mountains are buried under up to 4 kilometers of ice. They have been completely entombed for tens of millions of years, hidden from the surface world, untouched, preserved in a kind of geological deep freeze. Scientists first detected them in the 1950s through seismic surveys, bouncing sound waves through the ice to map what lay beneath. Decades later, improved radar systems flying across the continent in low passes began building the first real picture of what was down there. What emerged was astonishing. The mountains showed evidence of ancient river systems that once drained across their slopes, valleys that once carried meltwater, landscapes that once sat under open sky. And their origins are even older than the ice. Geologists believe the Gamburtsevs began forming when Gondwana, the ancient supercontinent that once united Antarctica, Africa, South America, Australia, and India, began to break apart hundreds of millions of years ago. The collision and rifting of tectonic plates pushed rock upward, creating these mountains long before Antarctica was ever cold, long before there was ice, long before the continent drifted south to the pole and the world began to freeze around it. The mountains survived all of it. The continental drift, the cooling climate, the arrival of the ice sheets. And they sit there now, perfectly preserved. A time capsule from a world that vanished before complex animal life had barely begun. We will likely never see them with our own eyes. But we know they're there, silent, ancient, impossibly old, waiting underneath the white. Antarctica is not the end of the world. It's a mirror, showing us what Earth looked like before we arrived, what it might look like long after we're gone, and what the rest of the universe might be hiding in its coldest, darkest corners. A hole in the sea ice that defies simple explanation. Ice that machines are only now learning to read. A bird that flew alongside dinosaurs in a world that no longer exists. Life thriving in absolute darkness, where no life should be. Mountains that have never felt sunlight in tens of millions of years. Every one of these discoveries was made not because Antarctica gave up its secrets easily, but because someone refused to stop asking questions in one of the most hostile, remote, and extraordinary places our planet has ever produced. The ice keeps its silence, but science, slowly, patiently, brilliantly, keeps listening. And the more it hears, the stranger and more remarkable this frozen world becomes.